Alright, so today we want to look at testing match pairs but using a non-parametric method. So if you're doing match pairs and your requirements for a t-test is not met and you want to do a non-parametric method, you could actually do a Wilcoxon sign rank test and use that to test match pairs of data. So in our data set here, so we have stores in north branches and south branches, and they had some sales before promotion and some sales after promotion. So we want to know if there was a difference in sales after the promotion, so we want to compare them. Right, so if you remember the requirements of a Wilcoxon sign rank test is that the sample must be a random sample, and as well the distribution of the differences between the two variables you're using in the match pair, those differences must have a distribution as symmetric. Not necessarily normally distributed, but it must be symmetric, right? So let's find the differences. So we go to transform, compute, and we'll create a new variable and we're going to call it differences. And we're going to have our pre-promo sales, subtract the post-promo sales. We click OK, and if we go to our data set, we see this new variable of differences. I will go to graph, histogram, send differences here. I will press OK, go back to output viewer, and here we're looking at this distribution here. And it looks fairly symmetric to me. Remember, it doesn't have to be perfectly symmetric, but the stronger the symmetry, the more accurate the p-value tends to be. So let's go back to our data set and let's perform the test. So go to analyze. We're doing a non-parametric. I will go to two related samples. So our first variable, our variable 1 would be our pre-promo sales, and then our post-promo sales would be our variable 2. We're going to do a Wilcoxon test, and we want to select OK. So for example, as well, we wanted to know what were the mean and medians if we want to compare these two variables. So let's go to analyze, descriptive frequencies. We leave mean, take off standard deviation, take off minimum, take off maximum, and we'll select median. Okay, and we're going to send across pre-promo and post-promo. We'll select OK. So let's go to our output view. Right, so the frequency table, we did not unselect that, so it still came up. So if we look in here and we see the mean, so pre-promo had a slightly lower mean than post-promo. If we look at the medians were the same. But will that mean that we do the test to tell us that there was no difference? No, not necessarily, right? So if we look here at the results of the test, the result of the test gave us a p-value that is 0.001 in the truth tail, right? And this is telling us that we reject our null hypothesis, and the null hypothesis would have been that saying the pre-promo sales would be equal to the post-promo sales, that there would be no difference. But this p-value, because it's less than 0.05, it tells us that we would have to reject that assumption. So folks, this is how we use the Wilcoxon sign rank test to test match pairs using a